This will be the notes for Chapter 9, Section 2. We'll start with our learning targets. We'll review the learning targets from Section 9.1. I can define and solve for kinetic energy. Remember from the last videos we talked about kinetic energy being the energy of motion, and we said that the formula for kinetic energy is Ke equals mv squared divided by 2. I can define and solve for gravitational potential energy. Gravitational potential energy, we said, is that when you lift an object, you do work on it, you use a force that is against the force of gravity, and that transfers energy to the object. That's gravitational potential energy. The formula for gravitational potential energy is GPE equals weight times height. I can list and explain other forms of energy. We talked about 6 other forms in the last video: thermal energy, chemical energy, electrical energy, sound energy, light energy, and nuclear energy. We'll talk more about these in class. The learning targets for today's section: I can explain energy conversion. Let's begin the notes for Section 9.2. Section 9.2 covers energy conversions. The first example I want to talk about is a ball falling off the desk. In the event that there is a ball sitting on the desk that does fall off, there's a change of energy from potential energy to kinetic energy. This can also be demonstrated in the picture below. The ball here has potential energy. That potential energy is then transferred to kinetic energy when the ball is released and dropped. Remember back to last section too, we could also say that this ball has gravitational potential energy based on its height and weight. In this next example, we look at a roller coaster. As a roller coaster car loses height, it gains speed. Potential energy is transformed into kinetic energy. As the coaster car gains height, it loses speed. Kinetic energy is transformed back into potential energy. The sum of the kinetic energy and potential energy is constant. This means that potential energy is the highest on top of the very first hill. Energy conversion is a change of one form of energy to another. Any form of energy can change into any other form of energy. Frequently, one form of energy changes into more than one other form. The diagram below shows a complex web of ways that energy can transform from one form to another and back again. This is a little bit simpler diagram that shows the same thing. In the center we have electrical energy, which is an important form of energy that we use frequently, and it shows the different ways that electrical energy can be transformed into thermal, chemical, light, sound, and mechanical energy. An example of energy conversion would be the energy conversion into chemical energy. This is something that you do every day without even realizing it. Food you eat is converted from chemical energy into energy to move, think, write, walk, and even use the restroom. All of this energy comes from the sun. Everything you eat can be traced back to plants. The small picture on the right shows food going to our usable forms of energy, NADPH and ATP, and that energy is then used for the body to do work. Photosynthesis is the process by which plants use light energy to make substances that have chemical energy. We talked about this briefly in the first section. Plants change light energy to chemical energy. Your body changes that chemical energy into kinetic energy. The picture below shows how light energy, carbon dioxide, and water are put into the plant, and the plant is able to put out carbohydrates and oxygen. Carbohydrates is another way of saying sugars, which we use for energy. Everything we do requires energy conversions. Some energy conversion examples: electrical energy is converted into sound every morning when your alarm clock wakes you. Thermal energy, toaster making toast. Or light energy would be a projector that I use in class. Here are some more examples of common energy conversions. In these examples, the column on the left shows electrical energy being transformed into things like heat or thermal energy, light energy, light, heat, and sound, like we would get from a computer, and movement, heat, and sound, like we would get from a blender. This picture is another form of energy conversion. In this picture, energy is converted from chemical to electrical to heat and light energy. Finally, I just want to give you a brief reminder about energy in machines. Remember, machines make work easier by changing the size or direction, or possibly both, of the force needed in order to do work. In the example on the left, the man pulling up the pulley, that box, is made easier by using that machine. The picture on the right shows the use of a lever and fulcrum, again, lifting a stone, making it easier. This is the end of section 9.2, talking about energy conversions. In the next section, we'll talk about the conservation of energy.